Hello everyone, my name is Ryan. Really glad to be here at NimConf today. I want to talk about a project that started as a small personal hobby and ended up becoming a light web engine built from scratch. It's called Rover. It all started when I was trying to update an RPG Maker game to use PixieGS version 8 and Web GPU. Simple enough, right? Except the runtime it depends on NVGS was massive. We are talking almost 300 megabytes. It's really got me thinking, do we really actually need to ship a full browser just to run a simple game? So I looked for an alternative and found Tauri. The concept made a lot of sense. Instead of building Chromium like Electron and NVGS, you just use the WebView already built into the operating system. WebView 2 on Windows, WebKit on Mac OS, the app size dropped dramatically. But there was a catch for me, Rust. I spent way too much time fighting borrow checkers and decoding long compiler errors instead of actually building my game. I want something that feels productive and honestly fun. And then I found Nim. Honestly, it felt almost too good to be true. It had the clean, readable feel of Python, the raw speed of C, and because it compiles down to C, integrating external libraries was very direct. I built the first version of Rover as a thin Nim wrapper around the system WebView, and it worked. Let me show you a small example of what I mean. The single line right here, static read, reads a file at compile time and embeds it directly into the binary. No runtime I/O, no asset bundler, no extra build step. The entire 3000 line of JavaScript runtime that Rover injects into every page is just a constant. In C, you will need an external tool to do this. In Rust, there is a macro for it. In Nim, it is just a function. And this is Nim talking directly to the Windows API. No header files, no wrapper library, just a pragma telling the compiler this function lives in coml g32dll, has this calling convention, and is imported under this name. That is the entire declaration. Nim treats C and the OS as a direct peer, not something you have to breathe across. While most projects in this space tend to design their own API layer, Rover takes a different approach. Instead of inventing new API that ultimately do the same thing, Rover implements API that developers already familiar and builds a compatible runtime underneath. That means users do not need to learn anything new, and any tutorial or documentation written for those established API is applied directly to the Rover as well. But then I ran into the next wall. What if you want to run your webcam on a platform that doesn't have a system web view? Think embedded device, retro game console, or environment where JIT compilation is completely banned. If you want to run a web app there, you have to bring your own engine. So I decided to build one. I called it RWebView. It is a custom rendering runtime written in Nim, powered by SDL3 and QuickJS. The key to making this doable was keeping the scope narrow. Just run HTML5 games, no layout engine at first, just Canvas 2D by Pluto VG, WebGL 1 and 2, web audio, and WebAssembly via Wormer. By stripping out the rest of the web complexity, we keep the engine genuinely lightweight. This brings us to a funny realization about how Rover evolved. If you look at how standard browsers are built, like Chrome or Firefox, they start from the top down. They build a complex HTML, CSS layout engine first, and then add Canvas or WebGL years later. Layout first, graphics second. Rover went in the exact opposite direction. Graphic first, it is a completely backward browser evolution. Same destination, completely opposite path. Nim is what held all of this together. Features like the compile pragma let us compile C source files directly alongside our Nim code. No complex CMake setup, no fragile binding generator. We just point to Pluto VG or Wormer and Nim builds it all. Compile time flags via when defined. Let us easily toggle features. The result is a codebase small enough that one developer can read and understand every single line of it. Thank you to Andreas and Peter and the NIM community for having me here. I'm genuinely proud to be part of this. Enjoy the rest of NimConf.